being part of this monsoon discussion from the start. Today I will be like to show you some of my high resolution CFS V2 simulation for how the model is going to do the seasonal forecast for this particular year. This is the same model which Monsoon mission also uses for the seasonal forecast, but we do for the R&D purpose. Okay, just before going to my results, I would like to, you may be all familiar, but I just wanted to tell you, this is the slide I got from Dr. Srijit from IMD Pune. This is the strategy they follow for releasing the seasonal forecast. Actually, as you know that there is a two-step process. First, in the month of April, there will be an all India rainfall monsoon forecast will come. And also, the IMD started giving the spatial distribution of rainfall. What IMD claim is that they use both multimodal ensemble based on CFS V2 as well as from the statistical model, which they do have many multi-parameter model. Then they will revise the forecast by the middle of May, in which again they will update this. Okay, I can also say that the first forecast may be coming based on the February initial condition. And then later they will update because by the time of May, they will get the April initial condition, the model will be ran and they will get the more updated information. With that, we will get the updated seasonal forecast. In addition to that, they do give homogeneous monsoon seasonal forecast for different zones. The recent additive is the core monsoon zone. Also, will be coming up. And in addition to this, every month, the IMD will give a probabilistic forecast, that is monthly forecast, which is completely based on dynamical model. In this, there is no statistical model input will be given. And another important outcome which will be coming from IMD is the monsoon onset. And it should be clear that you also may be familiar that monsoon onset doesn't have no relationship with the seasonal rainfall. Okay, with this background, let us, as I mentioned, we also do the experimental monsoon prediction using the same monsoon mission model. This has been implemented in CSIR Port Paradigm Institute in Bangalore in our HPC. And we have done a series of work, including myself and Rajendran and a couple of students. And what we have found was usually CFS V2 was identified that it has maximum skill if the model is initial conditions were used from February. But then our finding was you may not do an extensive simulation using all the initial condition covering February. Instead, if you take a few initial conditions from April and early May, that can also give equally good skill. For example, if you compare with the February initial condition versus the late April May initial condition, you get equivalent skill as well as absolute error is slightly better, what I can say. But the model has these studies have already identified and documented that model has a severe problem, like model is very much depending on the Pacific, that is on the ENSO and conditions. And the model also have a strong relationship between ENSO and ICCS. But ICCS and monsoon is opposite in the model. The model will never show any correlation with that too. Okay, with this background, okay, all these run which we have done previously was with the low resolution, that is T126. But recently, India Meteorological Department also moved to higher resolution, that is T382, which is about 38 kilometers over the equatorial region, spatial resolution. So we also modified, and this is the thing I wanted to update to Dr. Rajendran also, because we have now, earlier we used 79 to 2016, T126 for the all 5 initial condition, the Heinz experiment. Now I recomputed all this with the T382, starting from 79 to 2025. And for this today's presentation, because we are interested to see the coming monsoon, I have taken these 5 initial conditions and I also added 5 more ensembles, because for every day I have started, we can do more initial conditions are available, 0C and 0.6 every 6 hours apart. I have taken only two, 00C and 12C. So you will have a 10 member simulations. So how this model, the new model looks, the seasonal mean pattern with respect to IMD. This is the seasonal rainfall climatology between 81 to 2020. I have excluded last 5 years. I could have included that also, but the pattern may not change much. But what you can see here on the right side is the CFS V2 simulation. But here you can see a lot of gravity wave kind of. This is what Arindam has in the very beginning noticed, and today also I discussed with him whether he has implemented some changes to the code and removed this. Maybe I should also try to include in that how he has done in this. But this is one of the problem which is existing right now. Even with the Monsoon mission model, mean pattern also shows the same signal. Okay, now let us see for 2025. If I take the 10 ensemble mean June, July, August rainfall anomaly over a spatial scale, you can see this is our Indian region. So by and large, there are a lot of patchy thing because it is rainfall. And two with the resolution, but you are getting the small contours. But if you see by and large, there is a green area that shows that model is giving saying that about more than 10 percentage or about 10 percentage above normal rainfall over the Indian region. And this is how the global pattern looks like. Okay, now let us compare how this model performing in the last 10 years. For example, if you see this is CFSV2, the All India monsoon rainfall in millimeter, whereas this is CFSV2. Then okay, this is the percentage deviation. What is important is not the actual number. You can see the sign. But 18 and 19, and this is compared with the corresponding IMD observation. The sign is opposite in this model. These 2 years, the model couldn't capture 18 and 19, whereas all the other years model is able to get the sign correctly. And including this is the last year, the model was showing about plus 6.8, but actually it's about more than 11%. So this year is also showing the same kind of a number, but with a slightly less mean value.
You are getting 11% deviation last year.
11. This one.
Yeah, but IMD reports about 6 or 8%.
Yeah, but this is the actual value now.
Yes.
Correct. So IMD also had given only a 6.5 or something, but actually happened this.
So your mean rainfall very low, right? That's why you're getting plus 6.8, although your number is 8.3. You're getting plus 6.8 because your mean value is very low.
Correct.
Right?
Correct.
How much is it? Model making.
Okay. Okay, you wanted to see the climatological value.
Yeah, it's quite low. Now here comes to
it is always because actually that can be seen in my evolution, monsoon evolution. I have put a climatology graph in that. You can see.
They look comparable.
Correct. Yes.
So you have a dry bias, but now
is it not reflect?
The two columns pretty close. There's 8.3, okay, that's very much off.
Yes.
Yeah. The other one is 655, okay, that also.
Yeah.
Okay.
Okay. Yeah, this is from IMD, this year's probability forecast, which they have issued. Here it is, what I have shown is percentage deviation, but here it is, they classified into 3 groups and they were showing it. This is the first forecast issued using February initial condition, which has been updated with April initial condition, and it is available now. And there is a slight, mostly the changes occur over the southern peninsular region, which it was earlier reported as below normal. Now it is coming to be either normal or above normal. Okay, I have masked the ocean part and only took over Indian region, how the CFS V2 for ensemble percentage deviation looks like. What we can see that it is above 10% over the southern peninsular region, but there are below normal over these two pockets. That is over northeast and this one. But how far it is comparing with observation, we need to really see. But because though it is saying it is less, but there is already one spell of rainfall happened in northeast. Okay, but compared to rainfall, OLR gives you very smooth pattern. Here, but OLR shows that this can be the region which cloud free, mostly during the monsoon. But what is important to see here is how this evolution in individual months. For example, this is for June. So what we can see that June rain is by and large above normal in most of the places except some part of the northern Rajasthan and over this Orissa region. Whereas in July, model shows a fairly good rainfall over the core monsoon region, except over the Tamil Nadu region. But in August, model shows much less rain. And in September, again, it is showing large. One of the possibility may be because the model is started feeling that it is going to be a La Nina kind of situation. So then it is giving you above normal rainfall. But whether that is going to really happen or it will be neutral is a question. Okay, so then how this individual months, individual members looks like. So there is this model is very too sensitive to initial condition. You can see that there is a spread across all over, but there will be slightly skewed towards the positive side in the month of June. That is why we get a positive value in June. But whereas in July and September, it is mostly are on the positive side, except a few cases.
So interesting. That's the mean, you put a median.
Okay.
Median may be better measure than mean.
Okay.
Right?
Okay.
Mean might give a lot of weightage to the
Yes.
median. Worthwhile asking what the median is like.
Okay. Okay. Maybe.
So you have 10 of them. Okay, you have to take the middle one.
Correct.
Yeah, 3 plus, yeah, you will get almost 10 here. No, except July, look at July.
Yeah.
If you take a median, it will go up more. So you only 1 point below average.
Yes.
And one, that's average. And 5 is July. 5 of them well above it.
Correct. Correct. Correct.
July.
Oh, okay. In July. Yes. Yes.
Very skewed distribution. That's interesting. And September even was interesting. Maybe you like 2019, remember, 2019 September went way above. Maybe
correct. Correct. Okay, then next let us come to the onset of monsoon. This picture I took from IMD website yesterday. What we all might have seen that monsoon has had an early onset, and we had a severe rainfall during end of May in the Kerala. Then, but that rain is not accounted in the June to September monsoon, but we got fairly large amount of rainfall. And in fact, many of the rivers were flooded in Kerala. But then there was a immediately after 1st June, there was a break kind of a situation happened. Then rain again revived. And the last week again, it was fully flooded, raining severely, and many of the rivers are.
So you bring the onset in your condition now.
No, I didn't try for that. But,
See.
okay.
So your intent is not remembering.
Yes.
How?
Yeah, even the observed standard deviation is 8 days. So that is what, even though the monsoon this time is almost 8 days before, but it is still within that 8-day onset period. But what is interesting here is, but by today or yesterday, the monsoon is in the normal climatological value because about though the 8 days early onset, but because of that break period happened in between, monsoon didn't progress much. Okay, this is another part I just wanted to see how the monsoon rain. Okay, this is the actual station observation. IMD has about 138 observation point in Kerala. Whereas only 83 has now a continuous data which IMD is getting it. The other stations are either in under maintenance or with the data calibration issue. So what we can see here is this is the last 30 days that before the onset. That is, if I consider 24th May as the onset date, the 30 days before, actually, what usually we won't get even this much of rain. But this year, we during April, May, we got large amount of the thunder showers and a continuous rain as well. Because of that, there was no water problem in Kerala. Otherwise, it will be during this period, almost every places we will get water hotspots, and then the administration will be looking for that. This time there was no issue. That is because there was a fairly good amount of rain. Then if you come to 15 days from 24 May, as well got a lot of rainfall. And in the last 2 days from 24 means if you take 23, 24 or maybe 24 and 25, consider 24 as the onset, you see these are the pockets which we get always bigger rain. And this is the district is called Wayanad. That is the place where last year the landslide occurred. And you can see here in the district only three IMD rainfall observations, but the actual occurrence is somewhere in between. So that is why they say that during that particular week, even the day before, there was about 200 millimeter rain, but it was not captured by any of the IMD station because there was no observation. And here again, I want to say that the most of the observations are concentrated over the coastal or in the midland itself. But this part is actually highly elevated orography, about a kilometer high. In those places for maintenance purpose, IMD doesn't have, but other agencies, Kerala state agencies, they do have, like electricity board as well as irrigation department and forest department. They do have about 200 to 300 rain gauges are there, but that is for their purpose. And again, as I mentioned, they might not have done proper calibration. But if we can tap that much, then we get a fairly large number of rain gauges. So then comes to how the monsoon progressed after 25 to, this is the 2 days of accumulated rain. As you can see that northern part of Kerala got very heavy rain, and this every day we get the data from IMD, we prepare this plot and we will give to Kerala Disaster Management Authority because they will be focusing on these particular panchayat, and they will give a separate warning for them. Okay, now come to the model based day-to-day variation of rainfall. This is the seasonal evolution. As you can see here, the climatology. CFS V2 based climatology is the red line, whereas the IMD climatology is much above. So that is means the mean is always below than the actual observation. And what you can see here is if you see compare with the model climatology, we get fairly normal rain, but with a couple of spells here. That is what we getting that plus 5.6 or 6% more. And this is from IMD website from up to yesterday. You can see that there was a break spell here, and again monsoon got revived. This is for all India. This is for southern peninsula region, but you can see that there is a very good heavy rainfall spell in the last week, and it is the IMD forecast is going to be end by today or tomorrow, and there will be another spell of break. Then there will be another one more active spell is coming. That is what okay. And I also wanted to see how we in our study also we found that model is too correlated. The Indian monsoon is very much correlated with ENSO in the model. So in this particular year, this is the 10 different simulation shows. Basically the values are within the on the zero line. That means it is almost a normal condition only. So this is what IMD also got from based on April 25 initial condition. So they made this probabilistic forecast according to different seasons, starting from For example, the gray color is the probability of getting the coming year as neutral ENSO or La Nina or El Nino. So blue is for La Nina. So what is, you can see that the probability of becoming La Nina is more. This is what basically CFS V2 from IMD. And this is from other different models across the globe. That also shows by and large it is in the neutral condition will go. But the model shows that later part it will become La Nina. That is why in September we get larger rain. That is, I'm again showing it here. This is the actual SSB. But here I have a small issue, like if I take OISST, climatology, if I take something like a 30 or 40-year climatology, that is the purple line. So the model of even then this is the green line is the model climatology. The model climatology itself has a tendency that it will go a negative SST. So that will give, especially the end of the season, we will get a fairly good amount. By default, the model have that nature. In addition to that, if the temperature slightly go below this, model get an amplified rainfall for positive rainfall during the month of September. Okay, this is what and so IOD, and we have also seen how this model is able to, though there is no relationship in the model, and it is very clear that because many of the other global centers as well as shows that IOD is either neutral or in the later part it can be get slightly positive, but in our model it is entirely opposite. All the runs are showing that it is opposite phase, but actually observation doesn't show that. For example, this is the observation. This is from the CFS V2. That also shows what I showed before. And here, yeah, the plume also shows that there is a near zero IOD event. So this is what I think I have for this simulation based. So I will stop it here. Okay.
Can I see the time series of your rainfall 2025?
This one.
No, rainfall. You had a bar plot, right? Yeah. So that bar is that this year, right? Yeah.
What do you say?
The bar is this 2025, isn't it?
This is for this year,
Yeah.
2025. The other one is climatological, one is from observation IMD, one is from CFS V2. But you can see CFS V2 is always lower, except at the winter time, because model will be having more rain during winter.
Yeah, but the current active spray you could simulate correctly, but the break was not simulated. The break which you had before.
This one?
Yeah, it should have been bigger, larger break, but the right now active spray is correct.
Yeah, active is okay. But
That 18, 19 June or 15 June is always higher than normal.
According to your simulation,
this is ensemble me.
when you're showing IMD normal, it's above IMD normal, it's below your
See the red
below your own simulation.
This is the CFS V2.
So say by looking at that, got the impression that continue water, July and August is below normal, correct? Looking at this, am I right?
Oh, no.
July and August is below normal.
Above normal, no, because this is my.
With respect to IMD, but our normal.
Okay. That is fine. Okay. With the climatological IMD.
No. Everything is above normal. Yeah. Look like everything is above normal,
Yeah.
except August.
See the problem with
If you look at July,
yeah,
you got pretty high above normal.
above normal.
With respect to CFS people, right?
With respect to
How
CFS.
many of the people think?
With respect to CFS.
Not IMD.
No.
No, but this is not, okay. Well, your dry bias, you're getting a lot of this positive.
I didn't compare with IMDb.
Okay.
Yeah. Maybe.
Here is the question.
So in that model evolution which you are just showing that right now, and we have seen that in September CFSB2's mean is more than that of the IDs.
Yeah, this is what I saw now. Maybe I have to see further here, no? Yeah.
The last part.
Yeah, this part. That means the window.
Because of CFSB2 is a dry bias model. So what is happening in the September that is
See-
the source rules?
See, if you see the evolution part, that is what here I wanted to bring that issue here. See here, this is the actual observation, the seasonal cycle. But if you see the model climatological seasonal cycle have a tendency, especially towards a cold bias. So that can give a excess rain, possibly. I don't know. See, actually, we should not get this kind of a dip in the climatology. 1 year we may get that is internal variability, but it should also pass somewhere here. Why that is, I don't know. Is it totally different? This is OASST.
So this year looks like it's showing some kind of a La Nina kind of a condition here.
That's what. See, for example, this red line is the ensemble mean of this individual run. So the ensemble mean shows there is a La Nina will be building at the end of October to December. But it may not be real. It is a problem of model.
Yeah, so Rajendran covered most of it, so I'll just briefly give something. So this already has shown that there was a very long hiatus here. It's not the longest, 90 days, it was stuck near Bombay and then they shifted now. And this is a picture from India I took yesterday, showing clearly that the mean position of the ICCS, okay, right here. And so that's a shift you saw, sudden jump. And this is the forecast for the yesterday, last 2 days, and today and tomorrow, okay? And showing a lot of rain over the coast of Gujarat and something here in the Bay of Bengal and some rain in the Orissa region, okay? And let's look at what's the whole country. Of course, everything is negative according to the so far. So you go by this, then most of the forecasts of all the models we saw, including I think yours, may be wrong. Because if things are going this way, unless there's a recovery in the next 2 weeks, it's not going to be very good news. Now, this is the first previous week, it was even worse. Okay. Now, this is my favorite All India prediction, and you can see that it correctly predicted the weakening of the monsoon and correctly came with an increase, and then little thing, and then further increase, but it got this wrong. The 13th June part. I don't have the next thing. I hope I'll get it next week. So this is what I kept saying. The advantage of living in All India is whether it's able to get the weakening and strengthening the right place. Most of them gets it right. Now this is the data up to today, 18 June. You can see the last 3 days, All India has been well above normal. And you look at Central India, it's even better, 15 millimeters. Yesterday, today's is not there. Let me see what I have here. Yeah, this is a funny thing about the website. one part of the website shows 17th, one part shows the 18th. So I think they're not updated yet. So this is the core monsoon zone. You can see 1, 2, 3 really it has gone up comparatively. And this is where I think now the ITCC is in the monsoon core zone. And now if you look at all the 4 regions, I would say all of them are, except south, those are a good thing for the last few days. All of them are normal or above normal. Okay. Now this is the spatial plot up to today. And I just want you to remember this. It shows well above normal Gujarat, and this because of the rainfall that we saw in the windy data. And it shows this also, okay, pretty heavy. And most of this region is below normal. Now, this is up to 18th June in one part of the IMD website. Another part shows you a better graphics, but 1 day less. I don't know why. Okay, this part is a little confusing. The 17th June is negative. So I suspect that the rainfall that occurred yesterday, which was shown on the 18th June, was so high here that this scale is fine. That's only way I can explain the last figure and this figure. In 1 day, there's so much difference. So we are right now 17% below normal. And this is yesterday's rainfall reported today, and that explains why. This region got very high rainfall. 50% of all, that is blue, high, extremely heavy, extremely high. So this is what changed the 18-17 difference. And you can see large portion of Gujarat and all the regions got heavy rainfall. Now, this is what I looked at about 2 weeks back, forecast by GFS and ECMWF. I think both got it wrong because they are going up to 18 June. Okay, they are getting nothing. This is even worse. Here, the rainfall didn't progress much beyond this. Okay, so I think both of them were wrong in their 2 week forecast. Now, this is the monthly mean forecast, which also Rajendran has shown, and my suspicion is this may not come out right, but if the monsoon is very vigorous for 15 days, maybe it will show the structure. Okay. Now, but what's interesting is, if you look at the May list condition from multimodal CFS, which must be different from this, it shows a negative thing here. Okay. Then this is May, and look at April, that forecast may be correct. It's showing all below normal. Okay, so we'll see who's right, which condition gives us the right. Okay, now let's go to what ECMWF forecast which I discussed. I discussed the 1st May last time. Now it's 1st June. This has changed completely. It was here. So now it is saying June will be below normal. So 1 month made a huge difference. We don't know what caused the difference, but 1st May, I showed you it was right here. And 1st June is right below here. And it's showing July slightly above normal, August, September. So we'll continue to watch this ECMWF forecast. Okay, now I'm going to discuss briefly something I forgot last time. You remember Sumit Nigam, University of Maryland, makes forecast for the last 8 years. Okay. Now, the reason I want to discuss a little bit further is this is essentially machine learning technique. He is using SST data and rainfall data, okay, for the 116 years of data. Okay. So he has the observed rainfall, observed SST, and he's using machine learning to teach how to get the rainfall from SST. Okay. And so he has been doing this for quite some time. And I discussed this last year, and I was slightly critical of that thing because the way he gave the result. But now, after having seen it again, I want to correct my judgment somewhat. Okay. So this is the forecast for this year. Okay. He's showing below normal. This, even Rajendran showed this part, but he's showing below normal here also. Below normal over Kerala. So you have to watch out for that. And what Gujarat got, I mean, maybe get it right. And a few spots here. Okay. So we will look at this at the end of the season. But I'll also look at all his previous forecasts. And I'll talk to you about what I think is interesting about that. This is 2024. Okay. Now, last year I criticized it because the scale was not the same. Sorry, here the same scale. Sorry, here the scale is same, so it's very good. And I would argue that this is a good forecast because he got this wrong, he got this right, he got this right, he got that right. Okay. So if you look at not all India, if you look at regional features, I would say this model does it correctly. Okay. And he has used the right same color bar. Okay. But it doesn't do that always. I'll show you other results. So here I would say his 2024 forecast was success. As a matter of fact, your website, he made a claim that you got a very good forecast. Now, to me, this is very interesting because just based on SST data over the last 100 years and using machine learning to get the spatial pattern correctly, I think it's a big achievement. I mean, here and there you might miss out. Okay, that's okay. I would not call it a major. But spatial pattern, I think it's something there. So what it's saying is that SST anomalies all over the world, not just El Nino region and PDO region or Atlantic, all of them put together have a certain impact on the spatial pattern. So I think this is worth pursuing further. Those of you who do machine learning and other kinds of activities should look at it because this is not difficult. You have 100 years of data, you have it, everybody has it. You can play with it and see whether you can improve on this. Okay. Now let me go back to 2023. Which is also remarkably good, but I'm not happy about this color bar. It is 5 and 3.5 years. It is minus 3.5, minus 6. That's very confusing. Okay? That was the criticism last time. But my view now is forget about quantitative. Because when it comes to rainfall prediction, we have to be realistic. To expect a machine learning algorithm to get both spatial pattern and got it right is too much to ask. Okay, so we should be modest. So I would think that what Nigam should have done is just only two colors, above normal, below normal, and he'll be right. Okay, he's right here, he's right here also, small region, he's right here also. So I would say this is a very good forecast, but only ignore the quantitative part. So I'm interested not in the machine learning part, I'm interested in why. Why just SST data alone is able to give you the right spatial pattern. Okay, to me, this is a puzzle which needs to be solved from physics perspective. There's no physics here. This is pure brute force of the computer. Okay, you're going to see more and more of this in the next few years. But as an academic person, you have to ask, why is it coming? Why is it correctly predicting the spatial pattern? And since it's included SST all over the world, it says that we should not be just focusing on Nino 3.4 and PDO and IOD and Atlantic. There are a few more regions of influence. The main puzzle is how do they influence? The standard thing I've heard, which I never liked, is to say cause-seeking motion over India, which I think is nonsense. There's no point talking about it. When there is a drought in India, of course, there is less ascent. So in anomaly, you'll see seeking motion. That's not real seeking motion. In all of India's monsoon season, if you look at JJAS, even in a bad monsoon year, there'll be rising motion. Otherwise, there'll be no rain. Okay. So the real reason why this pattern is coming is still not clear. And tell you what is interesting about it. These are small regions. These are not whole country. There are changes in sign of the rainfall, which he's able to capture. So he has got something in it which needs further thing. Second thing I was puzzled, this based on the PhD thesis of Agnes and Gupta. And I'm unable to find a single publication. I'm unable to download his PhD. Even if you can use your clever access the internet to get downloaded, we should do that because we should know exactly what it is, whether there is any scope for improvement beyond what they have done. Okay. Okay. One more year, 2022. Okay. Again, I would say it's a great success. You ignore the color bar. This is what bothers me. Factor of two difference. I don't like people comparing model and output with different color bars. Okay. But if you're clear about your objective, that you only want to get the sign right, then instead of just two colors, below normal, you would have got it right. Except in Kerala. Okay. But Kerala, I can argue, is the tough to predict because it is orographic rain. Slight difference in wind speed would have made a difference. So I will not worry about it. He got this right, he got that right, and even this portion got it right. So I would say this is also success. If you only look for sign of change, not the magnitude. Now we come to 2021 and 2019. Okay. Now all of you know 2019 was a challenging year. September rainfall was absolutely above all wind. So he didn't do too bad. But still, I would argue, although this number is too large and the color bar is also too high, he got the sign right. He got this sign right. He got this sign right. Okay. Here, we don't know much because hardly any signature here. So I would say 2019 and 2021, I would say not so good because he gets possible values here which are not visible here. Okay. But again, he gets Mumbai really. I think very interesting. I'll tell you why. The reason that he gets the Mumbai right here, okay, and also Kerala right here, to me shows his jet correctly went for the north. So the orographic range is very simple to understand. Where is the jet maximum? Somali jet. If it is over Mumbai, Mumbai get more rainfall, Kerala get less rainfall. This is the long-term principle. Rajendran wrote about when he did work with Quito a long time back, 20-kilometer model, which we have discussed a lot here. That model shows due to global warming, the jet shifts north. Okay. So this is already showing signs of that kind of behavior. Okay, you've seen 2 more years. I think 1 more year here. That is, I forgot, on 2018. Okay. I would say 2018 is also a success. Although again, the color bar is the color bar is same. So I would say we got this right. We got this right. And there are some like, so over India has done a very good job. Okay. So we see 6 years or so, most of the time we get the sign correctly. So the question is, what is the information present in the SST anomaly pattern in the month of May? Remember, it's the month of May. He has no data for June, July, August. How is that able to imprint on the anomaly over India of JJS? Okay. So that is an interesting question. And I wish he had also done each month separately. We'll find out. It's quite possible he got each month wrong, but the average got right. All that is possible, but it's worth exploring. So all of you interested in machine learning, AI, I suggest get out of the SST data and the rainfall data available. Rainfall data is used, I think, in GPCC. We have a long time series of that. So see whether you can come up with a technique or a better technique to improve on this. But I think this has a lot of promise in my view. Okay, thank you. And next week is Arindam.
Okay, the focus that they have overcame now whenever it's negative. It's positive in the observation.
Okay.
I mean, the trend is kind of opposite to what he observes, usually in almost all the graphs that you showed. So you told that Kerala, over Kerala this year it's going to be lesser.
Yeah.
So if we follow this forecast and go with the bias direction, it might not be bad after the yes. It might be positive.
Yeah, but whatever, that's why I want to say. Look at it, please. Has he done past I don't think he has done. I think he has his own mean and subtracted. Right? So that's what he has done. But I'm curious as to how a purely machine learning algorithm seems to get the spatial pattern correction. but not the quantitative part. To me, that is an interesting step forward. I would not expect it. Okay? I'm very skeptical of machine learning, but just with the SSC data, is not using anything else, it's getting roughly the paper correct. Not all the time, but in a 6-year period, I think got 5 times. So that to me is something worth pursuing. Some of you may do a better job, use a more clever technique, I don't know. So that's what pursuing. Okay, nobody else? Thank you.